Welcome back to AWS reInvent. We're live from Las Vegas. We are on Twitch. My name is Julian. I'm a tech evangelist with AWS. I focus on machine learning. And in this session, we're going to talk about deep learning and some of the latest launches that we just announced. Before we do that, I would like to give our guests a chance to introduce themselves.
Hi, I'm Andrea Olgiati. I'm a principal engineer with AWS ML.
Hi, my name is Sukwon Kim. I'm the senior product manager of AWS AI.
And I'm Adrian, technical evangelist with AWS. I'm here to support Julian.
Hi, Adrian. All right, let's get to the topic. So deep learning has been super popular in the last few years, and one of the top problems that customers and developers face is training large, complex deep learning models on huge data sets. So can you tell us a little bit more about the challenges and the pain points that these people are facing?
Sure, well, I'll start. So training complex deep learning models requires a lot of CPU, a lot of GPU, and a lot of time to go through these massive data sets that you want to learn from.
Right.
And doing this on one GPU or one machine takes a really long time. We know of models that can take a month to train, right? And our customers have been telling us, and we at AWS have been looking at ways to make this process shorter, because the shorter your training process, the more your developers become productive. And it becomes a cycle that actually allows you to make innovation, as opposed to sit around and wait for machines to complete. So there's a bunch of ways where we can do this. One of them is through the use of SageMaker that can
Scale out
to however many GPU instances. We have B316XL instances that now they have 8 GPUs, and you can scale out as much as you want on SageMaker. And SageMaker takes care of a lot of the pain there. If that's not enough for you, if you want to get closer to the metal, then we offer a whole bunch of tools, from CloudFormation templates to a whole bunch of other scripts that allow you to set up a training cluster that has just the right properties that you like, that has just the right number of instances. We offer support for Horovod, which is a very popular synchronization framework for very large jobs. So there's a variety of tools that you can use.
But so when we push the needle into the red zone, right? We go from, let's say, 8 GPUs to 16 GPUs to 64 GPUs. Then that perfect linear scaling doesn't really happen anymore, right?
That's right. And what happens there is that these GPUs have to connect with each other. They have to talk to each other. And imagine it's the 4 of us. Each one of us learns something, and then we have to exchange the things that we learn.
Synchronization, communication.
Right. And making that happen and making it happen efficiently is hard. It is really hard. And fortunately, we did the work for our customers, and we put together a whole bunch of templates that allow this synchronization to be as efficient as we can. We have 25 gigabits networking that allows really high throughput between machines.
And we can go to 100,
And we can go to 100, we'll be able to go to 100.
That will make C5N and P3DN.
That's correct.
So this one goes to, it doesn't go to 11, it goes to 100 now.
But it will make a big difference, because a lot of the time during deep learning training, our customers find that they spend time waiting for machines to talk to each other.
Yeah.
So you have these very powerful GPUs that are sitting there waiting for synchronization. And this is something that the advances in Horovod, the advances in networking will help with.
All right, and now if we keep pushing that needle, and because we have some pretty big customers on AWS, and we do have customers who need to go up to maybe 256 GPUs, and well, a lot of the popular deep learning frameworks tend to, I don't want to say crumble under that pressure, but they don't perform so well. So one of the things we announced is the work that our own teams have done on TensorFlow, which is the most popular deep learning framework today. And we announced that we're contributing extra scalability to TensorFlow up to 256 GPUs. Can you imagine that? So can you explain? Can you talk a little bit about that, and maybe give us a couple of customer examples?
Sure.
Or use cases?
Sure. So TensorFlow 256 GPUs allow our customer to train in a scalable, near linear scalable manner. So we can achieve training time to train of 15 minutes of ResNet model under 15 minutes. So it will allow our customer to minimize the time to train as well as the training cost associated with that. So our customer can minimize cost as well as the time for developer usage. So it will allow our customer to achieve deep learning model training in a most cost-effective manner. So that will allow our customer to train convolutional neural network and computer vision models in very linearly scalable manner. And also we are able to achieve the linearly scaling training for kind of other RNN type of model, including deep speech. We were able to achieve more than 80% scalability.
Wow.
So now customer can train the model. Previously, it take around kind of 7 days for training that model with only one node.
That's long.
Yeah, that's pretty long. That consumes a lot of infrastructure cost as well as developer time.
Sure.
Now they can train this one within 3.5 hours, which is almost
Talk
with
about scalability.
yeah. This
From
is
7 days to
this
3
is a
hours?
kind of magic. Yeah, so
Yes.
that's what
Nice.
Andrea mentioned. Using our huge awesome network bandwidth and our infrastructure, we were able to utilize that as much as possible, and we can achieve this. So we believe a lot of Excel-sized customer in AWS can accelerate training performance and minimize the cost associated with that.
Yeah, and it's, I would like to remind all of you that it's not just about pure speed, because as a matter of fact, when you train deep learning models, you just don't train once, right? You train 10 times, 100 times. If you do a hyper-parameter optimization, the number of trainings that you're going to run explodes, right? So it's not just, okay, let's go from 7 days to 3 hours. It's literally being able, maybe in a couple of weeks, to train hundreds of models and get to optimal models much, much quicker and deliver more business value as well, right?
With that.
We're
It's not
talking
just a
weeks
race to
now,
the
huh?
finish, it's really increasing agility as well, right?
It's amazing. Yeah.
That is correct.
Yeah. All right, so well done, TensorFlow team. But it's not just about TensorFlow. We have other deep learning frameworks, and our customers use many different ones. And I know you did something pretty cool on Apache MXNet as well. So it's called dynamic training, right?
That's right.
So let's talk about that one too.
So dynamic training is an innovation that we delivered to Apache MXNet over the last few days, and it allows dynamic training clusters to shrink or grow in size. And this is something that, one more time, comes from our customers. We realized that our customers had maybe multiple training jobs running at the same time, maybe different researchers doing different experiments, and some succeed, some fail. But the ones that succeeded were going on a fixed set of numbers, fixed set of machines. We realized that we could give our customers business value by taking the machines of the experiments that failed and passing them on to the one that succeeded so that it could go faster. And so we had to make some fundamental changes inside MXNet, and we also had to deal with the scientific problem of making the training converge.
Sure.
And because you can make a system go faster, but if it doesn't converge, then you know better off.
Yeah, it's going to be a waste of time anyway. So let's dive a little deeper on that. So maybe not everybody's super familiar with distributed training, which is basically training a model with multiple instances. So let's talk about MXNet, but it works about the same for the other frameworks. So you would, as you said, you would pick a number of instances, right? As let's say maybe 4 machines, and those would collaborate for that training from A to Z, right? And well, if you figure halfway that this is a little too slow and you want to add actually more machines, well, you can't, and maybe you over provision a bit and it completes really quickly. But as you said, those machines would have been better used somewhere else. So it was elastic in the sense that you could pick a number of machines to begin with, but it was static in the sense that you had to keep those same machines all the way. And this is what you guys fixed.
That's correct.
Yeah? This is what you guys fixed.
And the cool part of it is that it integrates really well with AWS's reserved instances.
Yes. Oh yeah, cost optimization.
Because cost optimization. So now you have 10 machines, you're running 2 experiments with 5 machines each. 5 fail, and you can take those and flop them to the experiment that succeeded and keep that going at maximum speed. And we put together all the machinery to do that, and there's a very easy integration with the EC2 console, so that all you have to do is tag a machine to say, go to this cluster, and the next time, over a few minutes, the next cluster will pick it up and treat it as if it were there from the beginning. This also opens the door to use of on-spot instances.
So there was a question on Twitch exactly about that. Will that support a spot?
Yes, it will. It will. We still have some work to do. Tweak the final details, but yes, it will. And this is something that our customers are very excited about. And it's as Matt Wood said on Monday night, it's a foundational algorithm.
Yeah.
But it's the kind of thing that we see our customers really benefiting from.
So we believe this is a kind of philosophical change of training machine learning models. Previous training was pretty static, and then customer cannot control their infrastructure costs. How many idle instances are now kind of in their infrastructure pool, and then how they can optimize the use of infrastructure for this machine learning training. So we are relaxing those kind of static requirements to dynamic environments, so customer can optimize their infrastructure cost as well. So one great example of this customer use case is Chick-fil-A. So Chick-fil-A already provide us example for this dynamic training use case. They are training machine learning models for measuring the freshness of waffle in Chick-fil-A. And then this is computer vision model. And then they were able to, they believe they expect to minimize their training cost up to 20% using this dynamic training.
Yeah, and if we look back a few years, it's kind of similar to what EMR did. Our EMR is our managed environment for Hadoop and so on. They had spot integrations, and very quickly people realized, oh, for the same budget, I could, instead of running maybe 10 EMR nodes, now maybe I can run 100. And I can get my answer 10 times faster. So given the success that this feature had on EMR, I'm quite sure we'll see the same adoption and the same success on
cheaper,
dynamic
faster,
training.
more innovation.
Cheaper, faster, easy. Why not use it?
I believe so. And this also enables new uses within the same budget. For instance, during the daytime, researchers, maybe like yourselves, can use a bunch of machines to do whatever you have to do, and you want them to be interactive, you want them to be responsive. But at night, when you go home, you can release them into this pod and make the training jobs go faster because you have now bigger capacity
okay. So
in the night.
Your long-running jobs, like days, that have this baseline number of instances that they use, and then during the day, humans use other instances for experimentation, and then during the night give them back to speed up the long-running job. Oh, that's a cool idea. I like it. This is great.
What kind of innovation do you foresee our customers might do with this kind of new capabilities?
I think so. This will enable them to train larger, bigger models, because now when we have integration with Spot, they will be able to have many more instances in a training cluster. They'll be able to do things that prior were maybe cost maybe a little bit too expensive for them. They'll be able to give their researchers much more flexibility. And this is just the beginning.
Hyper optimization.
Think about this.
It's going to be super cheap with this.
So this one makes our customer getting closer to production of AI, right? So still customer thinks infrastructure cost of AI, how much it is expensive, and then how they can reduce the cost. So by providing this kind of flexibility, we are lowering the psychological barrier to our customers, so they can be more familiar with the infrastructure, they can have more clarity about how their cost structure will look like, how they can optimize their infrastructure usage. So we are making it easier for our enterprise developers to use machine learning model, and deploy them in production in a scalable manner. Yeah.
So we'll see machine learning models being used in way more tools and services eventually.
Yeah, next year will all be replaced by machine learning models. We can go enjoy Vegas a little more.
That is very true. We talked to a lot of customers who you don't associate with tech powerhouses.
Exactly. Yeah.
Right? Chick-fil-A, for instance.
Yeah, exactly.
Right? The NFL.
Yeah, absolutely.
There's a lot of
MLB
people, the MLB, who can get access to this technology through the infrastructure that we provide.
Yeah. Awesome.
All right, so how do customers get started with dynamic training? I know we have a blog post out. We have there's a GitHub repo. Any tips or any ideas to get started?
I think we have a ready-made example that our customer can start from. That's an awesome place to start. It trains a very popular computer vision model called ResNet 50 on a very well-known database. We have performance graphs and accuracy graphs well laid out, so you can actually follow what we did, start from zero, and try this out and see if it works for you.
All right, so go and try it. We have a few more minutes, and there's one more thing. There's always one more thing I would like to talk about. So we talked about training, right? And by the way, dynamic training will come to additional frameworks. It's not just MXNet. Okay, MXNet is just the first of the list. So we talked about training quite a bit, but let's talk about the other half. Inference, predicting. So we announced a new service called Elastic Inference, which I'm super excited about. So what kind of problems does it solve, and what are typical customer use cases for it?
And can you just say what inference is, maybe, to the audience?
Inference means predicting, right? It's just a mumbo jumbo data science machine learning work. And I'm guilty of that. Okay, so prediction.
So customers are running machine learning models for inference in the cloud, and then they will use either GPU or CPU. So currently, customers are running a lot of inferences on CPU, but customer wants to also run on inference on GPU, because GPU is also pretty performant infrastructure for our customers. And our customer wanted to minimize the cost associated with inference, because in many cases, customers are running machine learning models on almost every 24 hours to monitor something, security, or at some other computer vision use cases. So they always ask us to how they can minimize the infrastructure cost for running inference. So we are allowing our customer to elastically kind of use the resource of GPU instance. So instead of paying a full GPU instance infrastructure, they can pay whatever they use, so pay-as-you-go model. So customer can minimize their inference cost running on GPU instance. So we expect customer can reduce inference cost by up to 75% on GPU instances, which is a big deal.
And I think another benefit is you get to pick the instance size and type that works best for your app. So maybe you need C5. Well, it looks like my mic's dead. Maybe you need C5. Maybe you need M5. Maybe you need something else, right? Because your app, maybe it's a web app, maybe it's something else. Your app has very specific CPU and memory and I/O requirements, and that's what matters most, right? Prediction is maybe just a tiny bit in the app. So with Elastic Inference, you can select any EC2 instance, right, according to your app requirements, and then add the amount of GPU acceleration that you need. So it's literally the best of both worlds, right?
It's
no wasted resources anymore. Yeah?
I mean, I think the key point is that the Elastic Inference model allows you to specify the number of TOPS, operations per second, the power that you want. And then what happens behind the scenes is managed by us. Sure. And we provide just the teraops per second that you need. And that's something that our customers really ask for. That allows, because of the nature of AWS, we can provide a really cost-effective way of delivering those TOPS to our customers.
Cool. Any questions maybe from... No questions. All
the
right.
audience is very quiet.
Okay, yeah, machine learning is a little overwhelming sometimes. All right, so maybe we have maybe a minute or so left. What's the best way to get started with all of this? What would you? We have a lot of customers, a lot of companies who are always a little scared of machine learning and deep learning these fields to arcane or maybe a little weird. And we have all those launches. We had a ton of launches today. So with respect to TensorFlow scaling and dynamic training and elastic inference, how does one get started with all of this? What would you recommend?
My recommendation here would be to go to SageMaker and start from, there's a list of tens of notebooks. Notebooks are pieces of code, think of them as an IDE that runs in the cloud that you can just click on, and you have a complete working machine learning example at your fingertips.
Yeah, it's
you can take
interactive documentation in a way.
It's interactive documentation. They're very well written, very well explained, and they allow you to run these examples step by step. And you can inspect them if you want, or you can let them run all the way through. And there is, image classification. There's natural language processing. There's a whole bunch of them that you can try from SageMaker.
Yeah,
It's the
that's a
best way
great.
to
Yeah,
learn.
that's a great tip. I mean,
Yeah.
I cannot recommend this collection of
Yeah,
notebooks enough.
absolutely.
It's a great way to understand how SageMaker works, but above everything else, I think it's also a great way to get started with machine learning. So even if you're just starting, you'll learn a lot. So don't be afraid, just dive in, and in no time you'll be able to run all those fancy applications. All right, guys, thank you very much.
Thank you.
It was
so
a pleasure
much.
to have
Thank
you
you.
on
Thank you.
stage.
Thank you.
Thank you.
Thank you for listening, and please stay with us. We have many more sessions coming today.
Thank you, the internet.
Thank you.